Okay, so let's factor using rational numbers. X to the fourth minus 625. This is a difference of two squares because x to the fourth is a perfect square and 625 is also a perfect square. So we know that the factor should be one binomial and another binomial, and one of them is a sum and the other is a difference. So let's put for the first factor x squared minus square root of 625 is 25, and x squared plus 25. Now, since x squared minus 25 is another perfect square, then or is another difference of two squares rather, then we can still factor this, and we can put x plus 5, x minus 5. And we will just bring down the other factor that we can't factor anymore, which is x squared plus 25. So notice now that x to the fourth minus 625 has three factors: x plus 5, x minus 5, and x squared plus 25. Now, let's factor 81x x squared minus 16. 81x squared is a perfect square. 16 is a perfect square, so we have here a difference of two squares. So we have two binomial factors. The first factor we can have here 9x minus 4, and the second factor 9x plus 4. Since x is not squared, then 9x is not a perfect square. Therefore, we cannot factor anymore, and we stop here. Now let us factor 16x squared minus 81. 16x squared is a perfect square, 81 is a perfect square. So again, here we have a difference of two squares. So we know that we have two binomial factors. Let's put for the first binomial factor 4x plus 9, and the second factor 4x minus 9. None of them are perfect squares or difference of two squares. Like 4x is not a perfect square because x is not squared, so we stop here. All right, so now for this one, factor using real numbers. So that means we can use rationals and irrationals. Notice that 5x to the fifth is not a perfect square, and 20x is not a perfect square. So we cannot factor it the way we factored x to the fourth minus 625. But we notice that 5 is common to both 5 and 20. Also, these two terms both have x. So we can factor out 5x. And when we factor out 5x, we are going to end up having x to the fourth inside the parentheses. So that 5x times x to the fourth give us 5x to the fifth minus